Aloha, Richard Halverson here. This is ITS148, and today I'm going to do project 19.3. So let me share my screen. I'm going to do like this one here. All right, so if we look at it, project 3 in chapter 19. This is a problem where we extend the BST class, the binary search tree class, with a new class called MyBST, and we're supposed to add a method which will return the number of non-leaf nodes. Okay, and so they give you a nice hint thing to start with here. So let's copy that and go to it. And what do we have here? This is the BST class it gives you. And this is it uses a class called tree nodes, which is how it stores elements. And then this is what we're supposed to modify. It gives you this. And look, oh, it gives us the number of what? It gives us the number of non-leaf nodes. Okay, oh no, it gives us this, and this uses get number of leaves, and get number of leaves uses this get number of leaves 1, and get number of leaves 1 is what we have to write. So we have to write the method which will figure out how many leaves there are in the tree. And of course, a leaf is a node that has no children. Okay, so anyway, let's take this whole thing here. I'm going to copy it from here down to here, shift click, right click, copy, and I'm going to go to my test.py and paste it in here. And here it is. And I guess I need to write this code right here. All right, and so so the way this, so first it runs this, it checks out the number of non-leaves in an empty tree, non-leaf nodes. In an empty tree, all there is one node, and it's a leaf node. No, wait, an empty tree, it's got no nodes or no leaves. All right, number of non-leaves. All right, so we're supposed to write the number of leaves. So and we have the number of, okay, so let's see. So first of all, if the root is empty, if the root is nothing, if it's an empty tree without even a root, then the number of leaves is 0. So if root is equal to, if this pointer to the root is none, then we're going to return 0. There's 0 leaves in that tree. Else, if it's a node, okay, it's a node. Okay, it's not the case that the root is none. It's not the case that this is pointing to nothing. It's the case that this is pointing to a node. So it's not. So this is not true. So, however, if the root left is equal to none, and the root right is equal to none, it's got to be capital M. If that's true, then it's a leaf node. Okay, so we're going to return a 1, which means it is in fact a leaf node. Okay. Now, if this is not true and this is not true, if both of those are not true, that's the final else case, then we know that there must be a subtree, because it's going to be that either the left is not none, it's actually something, or the right is actually something. So that means that there is a subtree. So, we aren't sure which it is, but so what we're going to do is we're going to recursively call ourselves, and we're going to say num nodes, no, num leaves equals self get number of leaves get number of leaves 1 of root left. It's the number of leaves that are hanging off the left. It might be there might not be any, and it may be the right uh, child has the right node has the tree, the subtree. So we'll take care of that case also, and this is going to be the right. Okay, so and then that's what we return. So I think this will work. If this is called on a nothing, then it returns 0. It's 0 leaves. If this is called when there is a node there, but it has neither a left child or a right child, right subtree, neither a left subtree or a right subtree, then it's just sitting there. It's a node sitting there that doesn't have any leaves. No, it's a no. No, this is a leaf. It's 1 leaf. Okay, so it's able to return how many leaves it is. It's 1. And otherwise, there are more subtrees to look at. So that's what this does. This looks down the left subtree if it's there, and this looks down the right subtree if it's there. At least one of these is going to be there. It may be that both of them are there. And we know that at least one of them is going to be there, because otherwise it would be this that would have been true. Okay, so anyway, I think that should be enough. So you would now copy this into this and see what you get. All right, thanks for watching.